Okay, hi. Today's applications of linear systems, and this is just for solving problems where you have two variables and you don't know about it. One of the more difficult ones to deal with is usually flight or the canoe type issues. So we're going to talk a lot about those. The ones where, you don't know how fast the plane was going, you don't know how fast the wind was going, and it went cross country and then it came back. What was the speed of the wind in the plane? And you're like going, oh, I don't know. Why don't you look at the dial? Or stick a finger out the window with your, after wetting it with your mouth, that type of thing. So what we're going to do is really focus on those ones, okay? Okay, so let's say that a plane was traveling from point A to point B. Okay, so all of a sudden it flies from here to here, and we know its speed, but what was the actual plane traveling? Because you have to think about it. When you're traveling against it, if the wind is blowing this way, so if the wind is blowing this way, the plane's actually traveling at a certain speed, but it's traveling at a little less. Okay? So when it's traveling this way, the plane is going slower, and if it goes back this way, the plane will go faster, and it's called a tailwind and a headwind. Okay, and so those are the big issues we're going to be talking about. What about it? That type of thing. So if the plane is going this way, the plane's speed is going against the wind. So let's say that A is the speed of the wind, or the speed of the plane, and W is the speed of the wind. Okay, now as it comes back, A plus W, okay, is right there. Okay, so that's the actual speed of the plane. So the speed of the plane, you can tell by looking at the monitor, but what's the actual speed as we go through with this and stuff, okay? All right, so the actual speed of it going to its destination, let's say it was 495 miles per hour, was going to against the wind, and it coming back was 550 miles per hour. Okay, so what we do is we set up the two problems. We're going to have A plus W equals 550. Okay, then right below that we would have A minus W equals 495. Okay, now some of you guys who are already working with this know that, oh, elimination is going to work real fast, because if I add them together I get 2A equals, let me get my calculator, 550 plus 495 is 1045. And if I divide both sides by 2A, or by 2, I get A equals, let's divide by 2, 522.5 miles per hour. Okay, so it traveled at a constant speed in both directions at 522.5 miles per hour. Now, how much was the speed of the wind? What do you say? We actually plug that into A. I'm going to probably plug it into the first one just because I can subtract it. It makes it a lot easier. So 522.5 plus W equals 550. Okay, I minus 522.5 from both sides. Okay, and I can actually find out the speed of the wind this way. And I just go subtract. It'd be 27.5 miles per hour, and that's a heck of a wind going there. Now, obviously, this changes several times, and this hasn't an actual application of it. Well, it is, actually. It isn't in an actual representation of, because of the wind, because wind changes all the time. You go up higher in altitude for less wind, you go down lower in altitude for more wind, you can change several things. But this is just a simple problem that can be applied across all kinds of stuff. Now, this can also be used for boats. Oh, excuse me. All right, so instead of a boat, we actually had what was called a current. And a current, for those of you guys that aren't very big boaters, a current is just the direction of the water. So if you went upstream in the paddle in a canoe, it's going to be slower if you went downstream in the same canoe. So if you just change these things up, let's go ahead and get rid of them. Okay, so if the current's going this way and you went up current, This is actually quite interesting. If you went up current for, let's say, 3 hours, okay, and the total distance you went, and this one's actually a really good application, so make sure you're taking notes on this one. Okay, let's say the total distance was 1 mile, okay, and then you came back and it took you about half an hour. Okay. All right. So first thing you have to do is notice, oh, I'm given time and I've been given distance. Okay. To find rate, you take your distance and you divide it by time. Okay. So in this case, our speed is going to be going upstream. It's going to be 3 divided by 1. Well, shoot, 1 divided by 3. So it's going to be 1/3 of a mile per hour. Okay, so that's that first speed. Okay, all right, now going back downstream, okay, it's going to be distance, which is going to be 1 divided by 1/2, which is going to be the same as 2 miles per hour. Okay, so we can actually find the speed of the current this way too. So we're going to use, instead of B, I'm sorry, instead of A, we're going to use B. Okay. Oh, let's undo that. Okay. All right, so this is boat plus current, and this is boat, speed of boat minus current. Okay, and you set up the problem the same exact way. B plus C equals 2 over B minus C equals 1/3. Okay, and if you add them together, you get 2B equals 5/3. Okay, we divide both sides by that, and speed of the boat is going to be, let me see, you divide by 1/2, so you divide by 2, so you multiply by 1/2, so we get 5/6 of a miles per hour right here. Okay. All right, and actually to find the actual speed of the current, and this is a pretty strong current, you go 5/6 plus C equals 2. Okay, and C is going to be equal to 1 and 1/6 miles per hour. Okay. All right, and that's how you do the boat and the wind with the plane type of problems. That's how you do an actual application of linear systems.